this video, we will learn the operation of diode clipping circuits. Basically, diode clipping circuits are wave shaping circuits that are used to shape the portion of the waveform as per the requirement. In this experiment, we have a diode clipping circuit kit that has various components available onto the board. We can use any of these combinations to make a diode clipping circuit. We have various resistors, various diodes, Zener diodes, two DC power supplies that are capable of providing 0 to 10 volt at 10 milliamperes. We have a AC supply also that is varying between 0 to 12 volt AC at 50 Hz. Basically, clipper circuit is a kind of wave shaping circuit that is meant to control the shape of the voltage and current waveforms to suit various purposes. The output of the clipping circuit appears as if a portion of the input signal were clipped off. A clipping circuit requires a minimum of two components, that is, a diode and a resistor. Often DC battery is also used to fix the clipping level. The input waveform can be clipped at different levels by simply changing the battery voltage and by interchanging the position of various elements. Such circuits are used in radars and digital computers when it is desired to remove signal voltage above or below a specified voltage level. Another application is in radio receivers for communication circuits where noise pulses that rise well above the signal amplitude are clipped down to the desired level. Now we have another variant of biased parallel clipper circuit. Here we have a combination of resistance, diode and a DC supply connected like this. In this circuit, when in positive half cycle, when V in is less than this DC power supply V, in that case this diode is in off condition due to reverse bias condition, so we get output as per the input. As soon as this V in reaches at V, we get output equal to DC bias voltage. Now if input supply voltage goes below this DC voltage supply, then diode goes into the off condition and we will get output like this. Now we'll make the circuit connection as per this circuit diagram. So basically we'll connect this AC supply with one end of the resistor and other end of the resistor is connected with the anode of the diode. Cathode of the diode is connected with the positive DC supply. Negative end of the supply is connected with input like this. Now we can measure this is our input signal. We can measure the output across the diode positive terminal and negative terminal of the battery. So, in this way we are getting output like this. You can observe that a portion of positive half cycle is clipped off. Now you can observe the variation by changing the DC power supply. The level of the clip portion will be changed. you can observe the change in the clip portion level. So you can compare these two signals, input and output waveform, by keeping them at the same level. So here you can observe the variation in the clip portion. We have another bias parallel clipper. Here we have a resistance, a diode and a DC power supply connected in this manner. When V in is less than this DC bias voltage V, the diode conducts and we get output like this. We get fixed output V. As this V in increases beyond this DC power supply, the diode becomes forward biased. When V in is more negative than this DC bias voltage, this diode goes in off condition and we get output as per the applied input DC signal. So we will make the connections for this circuit. We have already made this kind of circuit. We just change the polarity of this DC power supply and we will get output like this. With the variation of the input signal, you can observe with the variation of this DC power supply, you can observe the output being clipped off. You can compare these two signals by putting them on the same level. You can observe that the same kind of output we are getting. You can observe the variation in the output by changing the DC level, DC bias of this level. We have another combination of resistance diode and DC bias to make it parallel clipper circuit. Here you can observe the polarities of the DC bias, the PN junction diode. In this circuit, when V in, that is input AC supply voltage, is less than this bias voltage, the diode remains in off condition and we get output like this. As soon as this V in becomes more negative than this DC bias voltage, diode deconducts and we get output equal to DC bias voltage, which is shown here. So now we will make the connections as per the circuit diagram. In earlier case, this diode was connected like this. Now we have to reverse the polarity of the diode, so we will use this diode. So in order to make use of this diode, we will connect this diode like this. You can observe that we are getting output like this. Green signal is our output. You can compare the output by placing them on the same level. You can see that a portion of the negative half cycle is being clipped up, that is being controlled by this DC bias voltage. You can observe the variation in the DC bias voltage is shown in the output waveform. Now we have another variant of parallel clipper circuit. The circuit is shown here. In this circuit, when V in is less than this bias voltage V, the diode remains in forward bias and it is turned on, so we get output equal to V. As soon as this V in is greater than this bias voltage, the diode comes into this reverse bias and it is turned off. So we get the input, we get a replica of the input in the output. So we'll make the connections as per the circuit diagram. In earlier connections we have the same kind of thing, only we have to change the polarity of the DC bias voltage. So we are changing this DC bias voltage like this, and in this way we will be able to get the output. Like this, you can see the output like this. The variation in the clipped portion can be seen by changing the bias voltage.